Hi students, last class we were discussing about chemical properties of phenols, that we discussed reactions of hydroxyl group. We know what are phenols. Phenol is a compound in which the hydroxyl group is directly attached to the benzene ring. Here now we are going to discuss about the reactions of benzene ring. OH group, which is attached to the benzene ring, is an activating group or an orthopara directing group. That means the incoming electrophile, this benzene ring is going to undergo electrophilic substitution reaction, aromatic electrophilic substitution reaction, and the incoming group X or Y is directed towards the ortho and para position. So as a result, the ortho para derivatives are formed from phenol. So that is, the incoming electrophile is directed towards ortho and para positions due to the presence of OH group attached to the benzene ring. Why the incoming electrophile is directed towards ortho and para positions? Because in phenol the oxygen atom of the OH group is electron rich. It has two lone pair of electron, which will increase the electron density in the benzene ring. At the electron density increases at ortho and para positions. Hence, the electrophilic substitution reaction takes place at ortho and para positions. So, phenols undergo electrophilic substitution reaction, and the substitution takes place at ortho and para position, as the hydroxyl group is a ortho para directing group. So, these are the reactions of the benzene ring of phenol. So this, let us consider this as a first reaction. In the presence of 20% nitric acid at 298 Kelvin, phenol forms two derivatives. One is an ortho-nitro derivative, the other is a para-nitro derivative. Ortho-nitrophenol and para-nitrophenol. So ortho-nitrophenol, here it is 30 to 40% yield, and para-nitrophenol is 15% yield in this case. This is an example for nitration reaction which takes place in the presence of dilute nitric acid. Same nitration can also take place in the presence of nitrating mixture. Nitrating mixture is a mixture of concentrated sulfuric and nitric acid. In the presence of sulfuric acid, nitric acid is able to furnish NO2 plus nitronium ion at 298 Kelvin. So here at the same time the ortho and para positions, all the three positions are substituted by nitronium ion or nitro group. You get 2,4,6 trinitrophenol. 2,4,6 trinitrophenol, which is very acidic in nature because this H plus is easily removed in the presence of the nitro group. So more than phenol, this 2,4,6 trinitrophenol is more acidic than actual phenol itself. So it is termed as picric acid. Okay, it is used as an explosive. It is used in the manufacture of dyes, medicines, etc. And so we discussed about two reactions, two types of nitration. One take place in the presence of 20% nitric acid. The other take place in the presence of nitrating mixture. The next reaction is nitrosation. Nitrous acid is treated, phenol is treated with nitrous acid at 278 Kelvin. The nitroso group HONO, nitrous acid is HONO, HON double bond O. This is the nitroso group supplied by nitrous acid, and this nitroso group NO plus act as an electrophile. OH minus is released. So this NO plus group is substituted at the para position, not at the ortho position, to avoid steric hindrance. So para nitrosophenol is the product which is formed. Okay, next reaction is bromination. Bromination in the presence of solvent carbon tetrachloride. Okay, so it is also called as halogenation. Here the halogen is bromine, that's all. So in the presence of carbon tetrachloride, it forms two derivatives. One is an ortho derivative, the other is a para derivative. Orthobromophenol and parabromophenol. phenol. Bromine atom is attached to the para position. Here Br bond Br, electrolytic fission take place, Br minus Br plus, bromonium ion is synthesized. This acts as an electrophile. Okay, this bromide ion combines with the H plus ion which is generated here, okay, by the phenol itself to form HBr. And halogenation, when it takes place in the presence of water as solvent, at the same time all the ortho and para positions are brominated or halogenated to form 2,4,6 tribromophenol, which is a white precipitate. This is considered as a test for phenol because bromine water is a red colored liquid. So when this red liquid is treated with phenol, the immediately white precipitate of 2,4,6 tribromophenol is obtained, which is a visible reaction, so it can act as a test for phenol. And the last reaction is sulfonation. Sulfonation, SO3H group, act as the electrophile, which is supplied by concentrated sulfuric acid. This SO3H group is substituted the ortho and para position. Here sulfonic acid is the more prioritized group, so it is named as ortho-hydroxy benzene sulfonic acid. Para-hydroxy benzene, para-hydroxy, with respect to this position, this is treated as para-hydroxy benzene sulfonic acid is formed. In all these cases, the ortho derivatives are minor products and the para derivatives are major products, because the steric hindrance of the atoms will be avoided in the case of para derivatives, so they are considered as major products. Okay, this reaction take place at the major product will be ortho derivative, can be ortho derivative at 280 Kelvin. The major product can be para derivative at 373 Kelvin. So generally when ortho and para derivative are formed at optimum temperature, the more the derivative which is major product is going to be para derivative. But if you want to get the ortho derivative, the temperature condition is given here. So the major product will be ortho derivative, ortho-hydroxy benzene sulfonic acid at 280 Kelvin. The major product will be para-hydroxy benzene sulfonic acid at 373 Kelvin. So these are some of the reactions of the benzene ring of phenol. Nitration with dilute nitric acid and nitrating mixture, and nitrosation in the presence of nitrous acid, and halogenation, bromine in the presence of carbon tetrachloride as solvent, bromine, water as solvent, and then sulfonation, concentrated sulfuric acid is used as the reagent. These are some of the important reactions of the benzene ring of phenol. We are going to discuss about certain named reactions of phenol in the next class. Thank you, children.